Hi guys, welcome to chapter 9, notes. So this chapter is about the distinction between outliers and high leverage observations and also influential points. So in this section, we're going to learn the difference between those. So there's a couple vocab words. So in general, right, or in short, an outlier is a data point whose response Y does not follow the general trend for the rest of the data. So the Y response is higher or lower than the rest of the trend of the data. Now, a data point has high leverage if it has extreme predictor X values. So what does this mean? It says with a single predictor, an extreme X value is simply one that is particularly high or low. With multiple predictors, extreme X values may be particularly high or low for one or more predictors, or may be unusual combinations of predictor values. Right, so as we go on, I know this is kind of a wordy definition, but as we go on, I will clarify that a little bit more. Okay. And it says, for our purposes, we consider a data point to be an outlier only if it's extreme with respect to the other Y values, not the X values. A data point is said to be influential if it unduly influences any part of the regression analysis. Okay, so influential points are points that somehow influence your regression analysis. So for example, when you run your linear regression, including that value and then excluding that value dramatically changes your correlation or your slope or something like that, okay? And so it says, such as the predicted responses, so the Y values, your predicted values, or the estimated slope coefficient, or the hypothesis test results. Now, we don't need to worry about that. We won't be doing hypothesis tests. So outliers and high leverage data points have the potential. I'm going to switch colors here. Outliers and high leverage points have the potential to be influential. So outliers could be influential points. High leverage points could be influential. They have the potential to be influential. But you generally have to investigate further to determine whether or not they are actually influential points. So all influential points are either outliers or high leverage points. However, not all outliers and not all high leverage points are influential. So it's one of those, all rectangles are squares, but not all squares are rectangles. So you have to investigate a little bit. One advantage of the case in which we have only one predictor is that we can look at a simple scatter plot in order to identify any outliers and influential points. Let's take a look at a few examples that should help us to clarify the distinction between those two types of extreme values. So example 1, based on the definitions above, do you think that the following data set contains any outliers or any high leverage points? So remember, an outlier will have, I'm going to go back, an outlier will be one whose Y response does not follow the pattern, but a high leverage points will have extreme X values. And so looking at these, we're looking for any data points that have any extreme Y values. And I mean, this one's a slight bit high, but I wouldn't call it an outlier. So no extreme Y values. I also see that there's no extreme X values, right? There's a cluster here. There's a slight gap, but I still wouldn't call those points leverage points because there's so many of them. So I like these notes because you're not going to do a lot of writing, but kind of hard because you're not going to do a lot of writing. So you got it. All of the data points follow the general trend. So there are no outliers in the Y direction, and none of the points are extreme with respect to X. So none of the points are extreme with respect to X. So there are also no high leverage points. Overall, none of the points would appear to be influential. So none of the points would appear to be influential. Example 2. All right, how about this example? We're going to flip to the next page. So, oh, my printer does that. It prints like right side up, then upside down, then right side up, then upside down. Okay, I apologize. Okay, now it's hard for you to see it, so I'll put it in pink. This pink point, right? So it says, do you think the following data set contains any outliers or any high leverage points? And so what I notice is that if I'm looking at the trend of the data, this one point has an extreme Y value. So the Y value, I shouldn't say the Y is high, but it's okay. The Y's are high here, right? And so we would consider this point to be an outlier. So because the red point does not follow the general trend of the rest of the data, and particularly because of the Y values, the Y value is high, we would consider this to be an outlier. Now, is the red data point influential? An easy way to determine that is to find the best fitting line twice. Once with the red data point included and once with the red data point excluded. So when they said you have to do some more investigation, I'm going to go back to here. It says, generally we have to investigate further. So I said that many times what you'll have to do is you'll have to do 2 different regression analyses. One including that point, this one, right, and one excluding the point. And so it's hard to tell, but it says, wow, it's hard to even tell the 2 regression equations apart. The solid line represents the estimated regression line with the red data point. So this is our solid. And then the dashed line represents the estimated regression equation with the data point excluded. And the lines of the 2 slopes are very similar. They give you the slopes, right? The slope is right here and right here. The slopes are not very different. Now the y-intercepts can change, but they had mentioned earlier that influential points will change the regression analysis, or they'll change the slope of the line or the correlation dramatically. And so you can see it didn't change the slope very much at all. So what we would say is that this data point is an outlier, but it's not influential. Okay. And we're going to skip this point, this part about the regression analysis. We will not be covering that this year because of our COVID-19 adjusted stats. But I do want to show you a regression analysis. It's called a Minitab output or a data tab output. So I'm going to show you some stuff that you do need to know. Right here, you need to know R squared is 91.3% and, or sorry, 91.01%. Now, these ones you can ignore. You only are looking for general R squared. And then you're going to need to look at this output right here where it says coefficients. This entire part is important. Normally, we need to know about the t-value and the p-value. Now, you guys know what a t-value is, and you also know what a p-value is. So a t-value is like your t or z, right? And then your p-value is the probability of seeing such a result. So, all right. So what we're looking at is, here's our constant. You need to understand our constant would be your y-intercept. So please make a note of that. This is your y-intercept line. And then our x. They actually called it x here, but they can use any letter they want here. They could have used, instead of using x, they could have said shoe size, if x were shoe size. Or they could have said length, if x were length. Okay, so we need to know the constant is always going to be your y-intercept, and then x will be the other item, or whatever is here will be the other item, and they don't always come in this order. And then you need to be able to read that regression equation. So there's your regression equation. All right, and this was, again, this was for when the data point was included. It got cut off, but this is including red. The red point, I'm sorry. And let me just triple check that I'm not off the... Oh, I'm off. Oh my gosh, I'm sorry, guys. Let me just... I'm glad I checked, but... So this was including the red point, so let me just go over that again. So r squared is right here. You don't need to worry about r squared adjusted or r squared predictor. You do need to worry about this entire thing right here. And this is your constant. Again, that's your y-intercept. And this is your other variable. So that's going to be your x variable, which is your slope. Now, I want you to notice, and then they gave you the regression equation. I want you to notice where these numbers show up here. So right here, that's your 2.96. And right here, that is your slope. So this column is very important. They could just give you an output like this and ask you to write the regression equation. All right. And if they asked you to find r here, you would take the square root of this value. So you take point, remember this is in a percent, so you change it to 0.9101, and you would square root that. So square root 0.9101, and you'd get that r is plus or minus 0.95399. Now this is a common error. This right here, forgetting the plus and minus. When you take the square root, you get two answers, a positive and a negative. The way you can tell if r is positive or if r is negative is to either look at your slope. If your slope is positive, then r is positive. Or look at your line. Your line is upward trending. That means r is positive. And so then we would drop our negative and say r is equal to 0.95. I'll just round it to 4. All right. Okay, so the next one with the red data point excluded, so we see our r squared value does increase, right? R squared went from 0.91 to 0.97, or from 91% correlated to 97%, and which also will change our r value. Again, we would just square root 0.9732, which would give me an r value of plus or minus 0.9865, right? Which tells me now plus or minus, again, because my correlation is positive, this would be r equals 0.987. But regardless, it's still a strong correlation, right? It does increase when we remove that red point, but it's still strongly correlated. And again, this column is really important to us. We've got our constant and then the x, and we need to be able to recognize where those values show up in your regression equation, which is right here. And so those values are the 1.73 is your y-intercept, and the slope is 5.177. And you can see that the slopes did not change dramatically. Also, I want you to notice the t-value and the p-value only in the x column. We don't care about the y. Remember, our x is our predictor variable, and that's if we were learning linear regression, we would be doing a regression analysis of the effect of x on y. So these would be important to us. Now you can see that the p-value was 0. That means and the same thing here, p-value. And t was 13.86. And t was 25.55. Now, if you have a t-value of 25.55, that's 25 standard deviations. Here's almost 14 standard deviations. The probability of something being that many standard deviations away is virtually 0. So you can see it does not change your conclusion. you would still reject the null hypothesis because your p-value would fall below any reasonable alpha. Again, we're not doing regression analysis, but you can see it does not affect the regression analysis. All right, so that's a little bit of a kind of a intro into using a table of data like this. And you may just have a table of data given to you. So it's really important, extremely important that you can read that table. Okay, so now there's some minor side effects of including the data points, but none are too serious. So the R-squared value has decreased slightly, as you could see, but you would still describe it as strong. Oh, I already said that. The standard error of the slope, which is used in calculating R. Okay, again, this is for beta 1 is your true slope, the line of the true slope of the true slope of the true line of best fit, but that's for regression analysis, so you don't need to worry about that too much. So the standard error changes a bit, and then it says, but B1 does not change that much, and if you were doing a hypothesis test in both cases, you would still reject the null. All right, so in short, it's an outlier, but not a influential point. Okay, next. Example 3, how about this example? So let's go ahead and flip over to that one. So now we have this data point out here that they're talking about. So do we think it's an outlier? Do you think it has high leverage? So what do you think? And so in this case, the red data point does follow the general trend of the rest of the data. Therefore, it is not deemed an outlier. So if you were to draw a line of best fit in something like this, right, you can see it generally does follow the trend of the data. However, right, this point does seem to have an extreme X value. So it does have high leverage. In fact, we would call this an extrapolation point. But I mean, if it were already included, then it's not extrapolating. But what I'm saying is, if they asked you, if the data ended here and they said, could you predict for somebody with, say, a 14, I don't know what this represents, but with 14, you'd say, no, that would be extrapolating beyond the data. All right, but also in this case, since it was already given to us, we would call this a high leverage point. All right, so it says, now to tell whether or not it's influential, right, we need to continue on. And so we're going to do two regressions, one with and one without the line. I'm sorry, the point. One with this point and one without the point. And it said it's hard to even tell the difference. It says that the solid line represents the estimated regression with the red data point included, and the dashed line represents the estimated regression equation with the red data point excluded. The slopes are very similar, 4.927 versus 5.11 respectively. And then it's going to talk about the regression analysis. So let's go look at the regression analysis. So again, here's our output, our R-squared value and our R-squared value. They don't change much at all. So here R-squared is 0.9774 and here it's 0.9732. So which would mean that our R values, so the square root of 0.9774 is R equals, I know it's positive because my trend line was positive, 0.9886. And R squared, if we square root the second one, 0.9732, R is equal to 0.9865. You can see this hardly changes your correlation whatsoever. Also, again, I'm going to tell you that I'm going to point out the important parts here, the coefficients. So here's our y-intercept. Where's my yellow one? There it is. And here's our slope. Please make sure you know how to identify those and write the equation of the line of best fit. Now, they don't put a hat over it, but remember, we would need to put a hat over anything that we write. So they should have a hat, but they don't. And so we've got 2.47 for our y-intercept here and 1.73 for our y-intercept here. And then here's our slope. Again, look at our t-values and our p-values. So here's our t-value. It's 25 standard deviations away versus 28. Here's our p-value, 0. So there are, I'm going to say that that point, since it does not change the regression analysis, nor does it affect the slope of the line, that point would not be influential, but it would be high leverage. And you can read the summary here. All right, last example. Do you think that this is an outlier, an influential point, high leverage point, right? So first, is it an outlier? So to be an outlier, its Y value needs to be very different from the rest of the data. And what I see is that if this is my trend line somewhere over here, this Y value is extremely large, right? So I'm going to say, yes, it's an outlier. And then also what I notice is that the data stops here and this goes past the data. So I would also say it's a high leverage point. Now to tell if it's influential, again, so I'll go back, it says right here, it says the red data point is most certainly an outlier and has high leverage. The red point does not follow the general trend of the data and it has an extreme X value. So both its X and Y values are extreme. Now they do a regression analysis on both with and without the data point. So it says, not surprisingly, the two lines are substantially different. The solid line represents the regression equation with the red data point, and the dashed line represents the regression equation with the red data point excluded. So included is this one, and this is without. And what we can see is that the lines dramatically change. So this point is influential. It is pulling the line of fit down to it. When we remove it, that line of fit can pop up. That's another big point too. Many times they'll ask you something like, if you remove this point, will the slope increase or decrease? And will this correlation increase or decrease? So to tell that, it's not always increase or decrease. It depends on where the point is. So when we remove it, R will most certainly increase. We can see that this correlation, or sorry, this point is not very well correlated to the rest of the trend of the data. So R will most certainly increase. But what would happen to our slope? Our slope in this case, the line would become more steep, and so the slope would also increase. But again, that's because of where this data point is. So let me give you another example. What if instead, I'm going to go back to this one. What if instead of this point, we had a point right here? So if I were to run the regression, right, this one's not there, it's this point now that we're using. If I were to run the regression with that point, what's going to happen to this line is that point is pulling my slope upward like this. So it's pulling my slope. And so in this case, if I remove that point, the slope will be still steeper, so it still will increase, but again, it would depend on where I put that point. So you need to be careful. And then, so we'll go ahead and look at the regression analysis again. I'm not going to go too deeply into it this time, but you can see where our regression equation matches these values and where our regression equation matches these values. You can see your R squared is very high here, and you can see your R squared is not very high here. And we'll look at R as well. So square root of 0.5519. R is 0.743. And then here, the square root of 0.9732, oh, we already did that one, sorry, is 0.987. So you can see you go from a moderate correlation to a strong correlation with the removal of just that one point. And then also, if you look at your regression analysis, though, look, if we were to do a hypothesis test on these, you would still have the same conclusion. So right here, it says in each case, you would still conclude that there's sufficient evidence to reject the null hypothesis. However, the t statistic changes dramatically from 25 to 4.8. So that is a big change. And so it says the predicted responses for the data point is that it would be both high leverage and an outlier, and it turned out to be influential too. I'm going to let you guys read the summary. We're not going to be doing any more with linear regression. So after this section of notes, which was really not much for you to do, just listen and write a few of your own notes down. We're now ready to begin mock testing. If you'd like some additional practice from chapter 8 or 9, please let me know and I'll give you some practice problems from the book. If I don't hear from you, I'll assume that you don't need that additional practice. But you're also always welcome to just go and, choose some problems out of the book and try them. You can choose odds, and then you'll, excuse me, and then you'll be able to check your answers. So, anyway, okay, so that's it. We're done with anything new. There's nothing new after this. Have a great day, guys.